Hey Scorpra, hope you're doing well. I gotta be honest, I'm already not feeling this playlist. Maybe I should just skip this song. I've only listened to one song, to be fair. If I don't like this song though, then we're doing a new one. Okay, it's good to hear. So we're working on this one. 15 streak, jeez, thank you. Um, so I think I wasn't that confident in it, but I think I answered A. Um, yeah, it feels okay to me, I guess. We can go. Well, is there a way we can think about? Is there a way we can check this? Like, is there a value of theta? Oops, what did I just do? Like, if theta is 0, we get. Well, no, I don't know if there's an easy way to check this. Let's just assume that I did this right, I guess. Where does the bead travel along the rail before it comes to rest? So, at the very beginning, it's given a small kick. We only have kinetic energy. The spring is relaxed at length 0. Friction has done no work. So 1/2 m v naught squared should equal potential energy from the spring plus work done by friction. There's no gravity in this system. X sine theta squared plus the integral from 0, because x is this diagonal distance, so it is a little bit weird to work with. Hey, Dora. Yes, starting off with some physics. Hope you're doing well. No, we should integrate from 0 to like some distance d. Because x is a variable, I think. I guess that's how I'm thinking of x. So working your thesis. Oh, I didn't realize that you're. I assume you're working on a PhD then? What is it on? Work done by friction should be positive, right? Or it's the sign of this should be positive. Master's thesis, maybe PhD after. Oh, nice. We're solving this thing for D. I guess like good luck with it. More in physics, the more I read it, the more I like it. More in. Fault-tolerant GNC controller for a 2D simulated satellite. That does not make sense. So it's not complete sense. I can guess what the 2D simulated satellite part means. The fault-tolerant GNC controller. That's, if that's just a little bit beyond me, uh, or that's not easily explained, then that's all good. Either way, I thought like a sick thing to be like just anything involving like space sounds pretty sick. So are you like, what is your master's going to be for? That's going pretty well, Fembox. Um, haven't done too much. I updated my the Discord server a bit, but other than that, just not been doing too much. How about you? This is gonna be pretty nasty. The one has can cancel. Just go to the center for the day. Not many students. Oh, interesting. I would guess that midterms are happening soon. Well, I don't think it's our semester or quarter, I guess, but GNC, Guidance and Navigation Control at Control Theory, Masters in Space Engineering. Ooh, aerospace without the arrow. That's awesome. That sounds like super interesting. I'd love to learn more about like astrophysics in general. But I figure if I'm still struggling with like mechanics questions like this, I'm probably not ready for it yet. Um, there's no way this is measuring distance, right? Is anything canceling mass? Maybe K is. Mu is unitless here. So wait, we have kg m squared s squared over kg. K is Newton per meter. Um, so Newton is kg m over s squared times 1 over m. By God, that is distance. We just get a meter squared, and then it gets square rooted. It's such an ugly number, though. Um, I don't think we can simplify it. You know what? This place was dumb. I don't like it. How about this one? Cinema? You like that? Pinloxo? Okay. Yeah, that happens change. I appreciate the thought though. It's going good. How about you? Under what condition does the bead start moving again back towards the vertex? So this is gonna be F equals MA. We need the spring force to be more powerful than, or the component of spring force parallel to the bar. Like, if the spring force is here, we want to get that component, which is going to be cosine pi over 2 minus theta, which is just sine pi, or which is just sine theta. To be greater than or equal to the force of static friction. Just my sleep schedule once again, so my day's in a total mess. I feel that. I'm in a constant battle with my sleep schedule. So the spring force, in this case, oh my god, dude. I'm just gonna use the letter D. I don't want to write out that entire square root unless I have to. Oh wait, no. It's not D, it's D sine theta. And then the force due to friction is mu times the normal force. In which case, or in this case, the mu static is equal to the mu kinetic. By the thing I wrote up here, it's just the spring force with the cosine theta slapped on it. So the D's just drop off? The K, the sine theta? Really? Sine and cosine are both positive over 0 to pi over 2, so we don't have to worry about dividing by a negative. K is positive, D is positive. Does that feel okay? Mu is less than secant theta. Oh, are you streaming, Dora? Let me follow you. First time yesterday? Oh, wow. Hey, if you want someone, if you want some more math type stuff in your life, then I think there would be people who are interested in talking about that. They probably, yeah, like, I mean, if you want my unsolicited uh, opinion here, like probably would want to throw something else like in there, but like it is good to have some type of like downtime activity, especially if you're first starting out. You're probably not gonna have like a bunch of people always engaging with you, so like you'd always have like that be your backup, and then if someone like pops in chat and wants to talk about something, then talk about that. But I don't know, it depends how you want to structure your stream. Like there are people just straight up do like co-working streams where it's basically like that. So I don't know, it depends like how you sell it. Like Hollow Nomi is a person who likes math, but his streams are just it's no even talking. Um, he just does his work, and people in chat do their work along with him. Researching thesis hot tub stream you'd watch. There you go, Central. Just to talk about space stuff. Yeah, there's a couple people I can think of who just like will do random stuff and then talk about like space stuff if someone wants to talk about it. Some like high potential, like I mean, the other people who come to mind are like people who do space focus streams like Nerduino or like Astro Canuck, but like I think that there's something that you can make work there. I'm missing something from the static friction term. Um, yeah, the question is like, what's the critical coefficient of friction? And the setup is like you have a rail here and another rail at an angle, and you have this weird spring attached to one part or attached to each rail, and you give that spring a little like kick to the right and observe how it behaves. And it's asking for the critical coefficient of friction where once it stops moving, it'll start to come back. Like I know that I have a minus sign in what I wrote up above here that I deleted, but I think that's okay. Mm, kind of like a pendulum, but not really. It like we're interested in the bead right there, and the bead is restricted to move along that angled rail. And the the angled rail also has like friction, which is where this is coming from. So yeah, it's not going to like go back and forth. The friction will make it stop. Hey, Freddie, do you ever get tired of doing these math streams? No. Um, The people come in and ask interesting questions or just hang out, keep it really fresh for me. Plus, it feels like a nice way to say that I've done something productive that day. Like, I've helped someone else hopefully um, get a better understanding of math. Oh, yeah, yeah. That is a very understandable thing. I mean FS for spring and FF for friction. Do I study math outside of stream? I go through spurts where I do. I've been studying some linear algebra off stream most recently, but it kind of depends on how much like energy I have. So I sometimes do, I sometimes don't. Oh yeah, for Freddie, I actually do. I have a gaming channel. The YouTube gaming channel is a little bit dead. To be honest, I need to upload to it more. I'm gonna put some Hollow Knight on it once I get around to actually doing that. Do I have a command to link to that? There's a link in the description. Uh, I don't have a command for it. It's Don does math and gaming though. But also on Twitch, I'll stream games as well. I think something missing from the Swing Force side of that inequality, really. Streamers don't exist off stream like teachers. Oh my god, dude, it's so weird. Like running into a teacher at like the grocery store or something. It's like, you exist here? So if I'm missing something from the Spring Force, then I've got a big issue because that would have missed my answer for B as well. Um, I don't see what's missing. The Spring Force is K times X. But since the spring is at an angle, like I have the distance D that I just worked out in the last problem. Think of the free body diagram. Yes, Central, you spelled meters wrong. Extended is right, but the meters is wrong. Hey, Harky. Yeah, Central just asked Chat GPT for some like smart things to say about the problem. Hey, 750. The free body diagram? I know you do, but you guys are wrong. um, yeah, what's the question? 750. And Edison has looks like an E&M problem. Okay, we're gonna take a little break from this mechanics problem here. You want to watch an anime 750 times in the movie 100 times? Oh yeah? from each other in the... So... Seems necessarily throwing out ideas. I mean, that's basically... Honestly, that's how, like, all of math and physics is constructed as far as I know. Taking a simple example and making it more complex. Average episode is... How long will it take? There are 2 movies. You see 2 hammers? You see right, Hargy. And so the equipotentials are, I guess, equally spaced between these. So like one is halfway, and the other 2 are halfway between the plates and the halfway. All right, you know what? Let's quickly do 750's little for fun question there. So you want to watch in the anime 700, or you need to do 750 minus 22 more times 12 episodes times 24 minutes each episode, plus you're going to watch the movie 100 minus 10 more times. There's only one movie that takes 90 minutes. 217,000 minutes. Wait, 2 movies? Oh, okay, two movies. $3,700. There you go. Hey Kim, thank you for the kind words. Two plus two, 4. Paint you a picture of a cat? I'm still thinking about how to do this question, so that'll be a nice like distraction. You can call me a Fita. I don't know how you pronounce it. I just assume that's how it's pronounced. It's been a minute since I've drawn a cat. Uh, it's a little. The cat's a little cross-eyed. Okay. There you go. Fita? Oh, okay. Gonna haunt your dreams. I'll take it. Um. So wait, 2 parallel plates. One is positive. Is this separated by a distance d? Does this just scale linearly? The field between 2 parallel plates is constant, right? Unless this isn't a... It should be a capacitor. One is positive, one is negative. Yeah, Papadoria. Like, I have a feeling, like, it would make sense to me if it's 15, 10, 5. Like, just going in equal increments. Um, I don't know if that's actually correct, though. Hey, Plasm. Yeah, sure. So you said intuitively, I'm not sure exactly why. Um, that's what I'm trying to figure out too. Hmm. See, now this looks basically like the same thing. And that kind of, like, these are equally spaced just visually. Maybe it's not trying to scale, to be fair, but wait, the equipotentials are evenly spaced in parallel. Let me go. Let me pull out the old E&M book. Row, null, and column space for a matrix. Oh, nice. I've just been looking at that. Let me get through this question from Edison, and then you'll be next. In that matrix, can you tell me what the size of that matrix is? Because it's going to be a little bit hard. I know it's hard to type a matrix into a chat. 4 by 4? Okay. What's the relationship between field and potential again? That's why, because the field is constant. Oh man, where is that picture that I love? Um, it's probably in chapter 2, right? No? Is it in... What did I do? You integrate E to get potential. Yeah, E or E is grad V. And if E is constant, V must have been linear. Yeah, I think that's how you would decide that, Edison. I think there should be a a different way of concluding that too, but I that's the way that I would know to do that. So yeah, I'm sorry I don't have like a like probably more satisfying answer, but I think that's the best that I can do for you. I do love a good E&M question though, so thank you for it. Okay, so Flasm, let's go to your question now. So this is a 4x4 matrix. Wow, it's gonna be that's like a big matrix to work with, but let's do it. So I assume you're going by rows here, but please correct me if I'm wrong. So it's like 2, -1, 0, 1, 5, 2, 1, -4, -1, -4, -1, 6, -8, -5, -2, 9. So Plasm, I hope you're still here. If you did step away, I understand, but let me know if that's the correct matrix there. Not sure how to start. Teacher can explain anything. Okay, so I would definitely start by row reducing this. So you don't need to go fully. Well, it probably helps to go fully to RREF. Um, this is an annoying one to do it for, but we oh, there's a 5. Um, no, let's just row reduce this thing. I'm gonna start by swapping row 1 and row 3 though. Just in the spirit of in the interest of time, I'm probably gonna compress some of these steps. Oh no! What? Oh, okay. That scared me. I'm gonna swap row 3 and row 1, and I'm gonna multiply row 3 through, or I'm gonna multiply this row through by -1 at the same time. Now let's take care of all of those things down below. So I'm going to subtract off 5 times row 1, subtract off 2 row 1, and add 8 row 1. What do we get here? Oh wait, I need a -6 up there. That, oh my god, dude. Actually, I'm gonna want to check this row reduction in Wolfram. But I'll keep doing it by hand for now. Um, you understand the okay? Maybe if you understand that, okay, then let's Wolfram it. Because I just realized that like this is, or I didn't just realize it. It's gonna take a while to do by hand. I'm making shit up, yeah. I'm just trying to buy time to plug this into Chat GPT. Wait, are these rows or columns? I can't remember. Uh, those are rows. Okay. Hey, Jasu. Class is horrible. I have the highest grade in the class, which is a 70. Oh no. I mean, Wolfram will tell us the answers to all this, but I'm going to pull from here as the RREF. I need to tell it to reduce it, I guess. Ooh. Interesting. Exactly. This thing, ooh, not bad. This thing is rank 2. Because we only have 2 pivots. Oops. So I expect immediately the dimension of the column space to be 2. And because the row space and column space have the same dimension, row space should also have 2 vectors in it. And then the null space is number of columns 4 minus the rank 2. So that's also 2. Like all these we expect to have 2 vectors inside of them. And let me actually like write that out. The dimension of the column space of this matrix that I'll call A. 2. Dimension of the row space. 2. Because it's the rank. Dimension of the null space is also 2 because it's 4 columns. Minus rank 2. So like the condensed version of that is n minus r for an m by n matrix. Okay. So the rank being 2 is kind of nice because the column space and row space we can get pretty quickly. To get the column space from a matrix like this, just choose the first 2 columns that are linearly independent. And so because it's 2, it's really easy to check if they're independent. Like they just can't be multiples of each other, and those first 2 certainly aren't. We want the basis of this, right? Well, yeah. So wait, you did say basis, right? Yeah. Let me put that into the original question. So just taking the first 2 columns. I think the more common thing is row space is column space of A transpose. Maybe we should write that instead. 1, 2, minus 4, minus 5. So these 2 vectors aren't scalar multiples of each other, so we're good to go. They do compute the Laplace transform as 6t squared by hand raising. They are allowed to use standard conversion table. Oh no. So for the row space, which is column space of A transpose, we do the same exact. We can just take the first 2 rows as long as they're not multiples of each other, and they don't seem to be. So Um, yeah, these would still be vertical vectors. There is a, I guess with the phrasing of the question, I am kind of debating, like, the row space of A, I think you would technically write them as row vectors. But the column space of A transpose, you write them as column vectors. I'm not sure if the distinction is all that important. That's more, my linear algebra is definitely not perfect. I think it's okay to write them as column vectors here, but be aware I might be wrong on that point. And then for the null space, we look at the free columns we have. So these are pivots. Everything that's not a pivot is a free column. And so we have to remember that the null space solves, or the null space is all vectors x that solves ax equals 0. So we have to imagine this as an augmented matrix with all zeros here. When we take the null space. And there's a procedure for finding a basis, which there's more options than just what we're doing, but the easiest thing to do is to think about the system of equations. So from the first row, we're going to get x1 plus 1/9 x3 minus 2/9 x4 equals 0. And from the second row, we'll get x2 plus 2/9 x3 minus 13/9 x4 equals 0. And so the procedure is that x3 and x4 are free variables. So just set one of your free variables to be 1, the rest of them to be 0, figure out what everything else has to be, and then repeat the process with each of your free variables. So first, let x3 equal 1 and x4 equal 0, because they're free variables. We're allowed to choose anything we want for them. So let's make the simplest choice. That's not just 0, 0, because that would be trivial then. Then from the first equation, x1 is 0. And from the second equation, x2 is also 0. So we get one vector that is 0, 0, 1, 0. And now we'll do the opposite. This matrix maybe isn't so interesting. Like you can get some different things for these null space vectors, but we're getting things that are almost like deceptively simple. But this time we'll let x3 be 0 and x4 be 1. Oh wait, I'm sorry. Oh my god, I can't believe I did that. I said that all wrong. I thought I solved it completely wrong in my head. I made x3 also 0. I just did the thing that I said not to do. Oh my god, that's so bad of me. If we let x3 be 1, I made it 0 in my head for some reason, and x4 be 0. We get x1 plus 1/9 equals 0. Oh my god. I was wondering why it looks so simple. So x1 is minus 1/9. From the second equation, we get x2 plus 2/9 is 0. So then x2 is minus 2/9. And that looks more reasonable. So minus 1/9, minus 2/9, 1, 0 is the first basis vector. So now if we do the reverse, we get x1 minus 2/9 is 0. So x1 is positive 2/9. In the second row, we get x2 minus 13/9 is 0. So x2 is 13/9. And so the basis vector we get from there is 2/9. I'm compressing this, but I'll write it out neater up top. 0 and 1. Okay, and so because in the null space things are specifically equal to the 0 vector, any multiple of these vectors also like satisfies the equation, because you could multiply each side of the equation through by say 2 and it still works because 2 times 0 is still 0. And so that's why the null space forms like its own, I guess, space. And we take every linear combination of these two vectors. So a basis for the null space, I keep running out of room. The first vector comma the second vector. 2/9, 13/9, 0, 1. So I hope that helps, Plasm. Let me know if you have any questions about what I did. Bluebird, how many row operations does not change the row space? Oh, you're right. Yeah, you're absolutely right, Bluebird. Bluebird is pointing out that what's simpler than, like, we got lucky by having things be ranked 2, so it's easy to check linear independence. But for the row space, you can just take whatever non-zero vectors as the basis for your row space from the RREF. The same is not true for columns. You can do column operations to figure that out, but if you have a more complicated matrix, Bixen? I don't know how to pronounce that, but welcome in. Thank you for the follow. Everyone from Spain. Oh, nice. Oh, that does look like a Spanish word. Now I look at it. Awesome to have you. But yeah, a simpler basis for the row space are just these vectors here. Yeah, we're almost at the end of this question here, so if you had a question, feel free to let us know. Probability. Okay, it's not my strongest suit, but I can try. I haven't seen anything new from Plasma in a minute, so if I don't hear anything else, I am just gonna move on. Oh, I've seen this exact type of problem before. And I think it's trickier than it might seem. N equals 3, the answer is 1. There you go. Also, for that last problem, thank God for Strang. And I've been watching those lectures. I've not have been able to do this question. Oh wait, no, this is a different version of the question that I was thinking. I've seen a more complicated version where they can sit in different rows also, I think. Well, maybe that's not that much more complicated. Um, how do we think about this? I think maybe it's going to be helpful to look for a pattern here. Like starting like n equals 3 is obviously 1, but let's start with n equals 4. And let's just like build up a pattern because I'm not sure how to do it just straight off the bat. There's only 2 situations where all 3 sit next to each other. But it changes depending on the first person's choice of seat, doesn't it? Okay, let's, if the first person chooses 1 times 2/3 times 1/2. Except if the person starts by choosing a seat right here on the edge. Then it's 1 out of 4. That's the tricky bit. So we need to do different cases, I guess. So let's start with the middle seat. I think that's what you said, where 1 times 2/3, because you start with that, and then there's 2 good choices. Oh, but then there's cases in that too. Because if the second person chooses that one, then we have the same issue. What the hell? I think. Wait, is there a trick for thinking about this where you? Like, I think it's easier to get. What is it? Yeah, I think this is very quickly going to become too complicated. And there should be a trick here. N minus 2 times 6 over n choose 3. Yeah, I'm thinking. Well, I'm thinking of a different formula. There's 4 choose 3 total arrangements of people in these seats, right? But there's only 2 good scenarios, which is here and here, or like these 3 seats, or these 3 seats. So it would be 2 over the total number of possibilities. And so that seems to fit with the formula that Femblox, well, the times 6, I'm not sure where that's coming from. But this seems to fit with the formula that Lubert is saying, at least. Let's just check it through for n equals 5, though. 1, 2, 3, 4, 5. So here there's, again, 5 choose 3 total arrangements for 3 people. Okay, I'll go Aka. I'm not sure where that formula is coming from. It might be Or it looks a little weird. um, Here there's three good scenarios, like that, and that, or that, and that, or that, and that. And so we could go through it for 6 as well, but it looks like the pattern that I'm getting here is n minus 2 over n choose 3. I in theory I've just found the answer, Banga, but if you have a suggestion, please give it. To bring the 3 consecutive seats into a couch, there are n minus 2 places the couch could fit. There are 3 ways to arrange themselves on the couch. Right. Or 3 factorial ways. That's where the 6 is coming from. Okay. Yeah, I like that. I did miss that. So, the issue with my train of thinking is that I was treating people as interchangeable. I was saying like this, like these 3 seats are an acceptable arrangement, but within these 3 seats, these are 3 different people. And so you could have the same 3 people sitting in these same 3 seats in different orders. And there's 3, like, you know, the first person has 3 seats to choose from, the next person has 2 seats to choose from, the final person has 1 seat to choose from. So that's where the 3 factorial comes from. Uh, Really? It'd be NP3 in the bottom? You probably are right. The order does matter. Yeah, I guess I was wrong with saying choose. Okay. So I guess I made another mistake, which is in counting the total number of cases. Since we're saying that the order matters here, we do need to account for that in the total number of cases also, I think. And so instead of n choose 3, you'd be doing np3. But as Lou were just pointing out, this actually np3 over 3 factorial is the same thing as n choose 3 factorial. So we could also have written just 2 over... Sorry, that should have been 4. Choose 3 in this case. 4, choose 3. What does n equals 4 give us? Let's find out. Um, 2 times 3 factorial over... How do you... Is it just... Can I just do 4p3? That's not right. Ugh. What's the combination permutation? I'll just put the factorials in myself. So 4 factorial over 1 factorial? So it's just 4 factorial? Half? It's a 50-50 shot? Is that true? That seems high, right? How many scenarios do we have? One? No. 2. Oh, there's only 2 scenarios where it doesn't work, right? Okay, so this does work for n equals 4. Hmm. The ratio of 6 to the product of the total number of seats and 1 less than the total number of seats. I don't know what that means, Benga. Hey, Phobos. I think we have the answer, though. So, Vixen, that I'm sure I'm pronouncing wrong. I think either of these 2 formulas are acceptable. To my eyes. And the way we did that was just by looking at simple cases and looking for a pattern. And the issue that I always have with these types of questions is I can't explain why other things are wrong, to be honest. Or that's always a very like difficult task. Teacher asks you to prove it. I mean, I feel like I don't know how you're supposed to necessarily like prove a question like this. Like I feel like if I was writing out in words, be like, there are NP 3 total ways to sit the 3 people in the row if order matters. There are n-2 ways to sit 3 people together, and 3 factorial ways to arrange the people within those 3 seats. So the probability is, and the formula that we just said. Stars and bars? I'm not sure. We just kind of did this by looking for patterns. Yeah, Benga, sure. Oh, sorry, yeah, that's like notation for permutation. I think there's a lot of other notations that exist for this. But it's like, if you've seen like this type of NCR, I was thinking doing the same thing with P. But you might see like P of N comma R, which probably honestly better. Parth, type it there in chat or put it in my Discord. I'm just looking at something quick. But I think I've got an answer for the problem here. It sounds like Benga might want to add something to it in the Discord, but I think this is just the answer. What level can I solve? It kind of depends on the question, Parth, to be honest. Like, that's a hard question to answer, but in general, I'm best with things that are like first year university and earlier. Write a program? I guess I could if there's a break. You're feeling judgmental today? Oh, good. An impromptu code roast. Um, Let me take the answers that we said, because this and it's probably the same thing, yeah. Because this P of n3 thing, it's just a formula with factorials. It's n factorial over n minus 3 factorial. And C of n3 is n factorial over 3 factorial, n minus 3 factorial. And so the answer, if I take that one and just translate it into the factorial notation, n minus 2, 3 factorial over n factorial over n minus 3 factorial. And this is also the same thing as what your friend got, yeah, as Fembach said. Because we can flip this 3 all the way down, and it's the same thing. So we agree with your friend. So yeah, if you haven't learned this like P and C thing, I probably just keep it as the factorials then, but that's where it's coming from. Yeah, no worries. Thank you for the question. Okay, we might have a little bit of downtime. We could try and satisfy Phobos's like judgmental lust here. Like I could just bust out a Project Euler problem or something. I don't know. I'm not signed in anymore. It's been that long. 1 second. You kidding? I can't remember my password anyway. What would I mean my password? Is it this? Okay, I can't figure out what my password is anyway. Oh, and Bixen, if you are still here, no pressure, but if you ever have a math question in the future, and I'm not around, here's a whole list of people who also stream math on Twitch. So I just like to let people know that I'm not the only one who does this. Yeah, no worries. Hey, Obi. And for anyone who might be like working and might need math help, it's like those people who I like can generally recommend for like math stuff. We all have our own like strengths and weaknesses, but yeah. All right, Parth. I see you just joined the Discord. Let me know when you've actually posted something, and I'll take a look. In the meantime, I'm just gonna look at this just to fill in some time. So Femlux was throwing shade on my spring force. Oh, I'm supposed to be taking a component of the spring force. I said that out loud, and I didn't actually do it. I see now. But I think the spring force is right up here is fine. That's pointing in this direction, but I want this component of the spring force, and I just didn't even say that. Oh no, I know what I did. Or I think I know what I did. The spring force already has the sine theta built into it for the distance. And I think I realized I should have included a sine theta to get this component here, because cosine pi over 2 minus theta is sine theta, but I just combined them in my head, so this should be sine squared, right? We need another... sine, and that transfers into a tangent. So oh, let's see. This is related to the problem that Bixen asked. This is what Benga put. Total waves p of n comma 3. Favorable waves n minus 2 times 3. Favorable waves over total waves. Okay. Wait. Oh, so you simplified the factorial is the difference here. That is a nice, like, that's even simpler, yeah. I only brought it to like this stage, but you definitely could clean that up more. Okay, well, nice. Because I was confused when your answer didn't include any factor. I was like, where does that come from? But it is just the same thing as we have, but like simplified. Okay. And so does this tan theta value make sense? When theta is close to 0, mu needs to be very small in order for it to come back. I guess so, because the spring can't be exerting that much force. Is that the idea? Like, if theta is very small, the spring has to be pretty frickin' short. And the opposite is true. Like, mu is getting arbitrarily large the closer we get to 90 degrees. Yeah, I was working on this question on Tuesday. I didn't finish it, though. As theta gets close to 90... Oh, yeah, okay, this is a more instructive thing to think about, because as theta gets close to 90, you have a very wide window of acceptable mu's, because the spring is nearly vertical. The normal force is very small. That's not a spring. So, like, there's almost no normal force on this rail, so mu would have to be huge in order to stop it. Okay, so I think tangent theta makes sense. Interesting, it doesn't depend on k. I guess because the normal force also depends on k. So it cancels. Assuming the bead does indeed, so part D. Assuming the bead does indeed start moving again, what is its speed when it arrives back at the vertex? I guess we want energy. We know how far the string is stretched in this case. Well, the version from getting there doesn't matter. Okay. So we start with spring potential energy, 1/2 kd squared, where d is this monster of a number. We're going to set it equal to kinetic energy plus work done by friction. Do I really need the integral every time? I did the exact same integral up here. It is the same, right? It's the, yeah. The only that's different is the direction, but we don't care about that. Oh, d theta. Yeah, I think this is okay. And we're solving for v. All right, the 1/2s drop out. Can we one-shot this? Like that? Is this velocity? Um, Newtons per meter squared per kg square rooted. In Newton, it's kg m per s squared over m. That is indeed meters per second. Look at me go. I think we're checking the answer on this. I can simplify? Can I? Oh, if I involve d? Yeah, I shouldn't have my answer be in terms of d, right? Okay. This is d squared and not just d. Hey Lucas, mechanics is physics of like physical motion, I guess. So there's no electricity or things like that. It's like the physics of a ball rolling down a ramp or something like that. Yeah, I think it's the simplest way that I could explain it. Oh, like YouTube's? You? It, I think it's kind of you, yeah. I don't disagree. It's good. It's good to know, but it's not my favorite. It's really annoying. I don't think we get any cancellations with the trig stuff though. The sine squared, we can make it like something with cosine 2 theta. I don't think we want to do that though. To be honest, I hated physics until I self-studied it, and now I really like it. I don't think I had very good like physics teachers previously. Yeah, I really wish it'd simplify it, but I don't think it does. So I guess my answer is going to be this. You have something a little simpler? Math's just numbers come with knowing how the shit behind it works. That can be a helpful thing though, because like you can expect the numbers to look a certain way based off the situation. Like it can be a check for whether you're right or wrong. What are my trig identities? Theta? You probably mean like the thing that I'm even like writing here? It's Greek letter theta. Um, it's just a letter that's commonly used to be an angle. So theta is that angle right there. It could be like 30 degrees or something. Alpha is sometimes used too. Is something missing on the left-hand side? That's not uncommon. Um, if there's multiple angles involved. It might also just go by country too. Like, if there's only one angle involved, we usually use theta here. But if there's multiple angles, then we get into alpha, beta, gamma. Just go down the line. I don't think anything's missing from the left-hand side. Is there something missing from the left-hand side? Oh, wait. Oh, no, I need a... I know I know what's missing. Ah, who even likes trig? I need another sine theta, don't I? Because D is... Wait, D is that distance? What distance is D? How far... Oh, this is not an accurate representation of D. We need to sine theta. Sine squared. Okay. We still don't get a cancellation though. The sign is wrong. Unless friction. Unless I have a sign wrong somewhere else too. Are you sent a problem, Adam? Oh, I see it now. It helps me if you type something in chat like you just did. 'Cause I just check the Discord like periodically when I'm on stream. Let me. I need to remember to erase. I'm just gonna erase this so I remember to fix it later. We got a double integral to work on. Secant squared of cosine? Oh my god. What? This looks terrible. Let's just think, like, can we figure out this integral, or do we need to do some bound switching? The obvious thing seems to be u equals cosine x. Oh. Is it really? Think we need to switch the bounds? Yeah, let me just plug that into. Let me plug that single integral into Wolfram Alpha and see how much it hates me. It does seem like one where you should probably switch the bounds, though. You're not gonna have to do a double integral like this next year. You at least. Okay, yeah, Wolfram Alpha can't figure out how to do that, and neither can I. So we'll probably have to do some bound switching. Down does Wolfram. For a problem like this, shamelessly, yeah. Okay, so what are we integrating over? Okay, so we're going from x equals arc sine y to x equals pi over 2. So if x is arc sine y, then y is sine of x, and that's a normal graph. Pretend pi over 2 is over here. 1 is right there. And then y goes from 0 to 1. X goes from here to here. So we're integrating over this region here. Okay, good. So if we want to switch these bounds, we need to start with y. Y goes from 0 up to sine of x. x simply goes from 0 to pi over 2. Hopefully this is simpler. Oh, hey, it should be. Yeah, yeah. It gives us the use of that I think we want. Yeah, it does. It does. Wow. So we're integrating the y first. So I'll write this out because I don't know how comfortable you are with double integrals like this. If we integrate with respect to y, we get just y, and that's going to be evaluated from 0 to sine x. dx. So then now we take the y and we plug in sine x. Secant squared or cosine x. Sine x, and then from 0 we just get 0, so I'm not going to write that. And now we get the u sub that jumps out, but it actually works this time. So if we take u equal to cosine x, du is negative sine x dx. I'm just going to drop off the bounds for now. So we get just secant squared u du. Negative. Perfect. And so that is just tangent, negative tangent. Then we unsub when we bring the bounds back. Cosine pi over 2 is 0. Cosine of 0 is 1. Tangent of 0 is 0. Tangent of 1 doesn't simplify, I don't think. So I guess it's tangent 1. I want to verify this, though. It's been a minute since I've done this type of problem. I feel pretty good about it, though. Pretty sure that's correct? It feels correct. One 1.55741. What is tangent of 1? Bam! Look at me go. So yeah, let me know if you have any questions about how I did that one, Adam, but otherwise, thank you for the question. Oh, wait. No, not bam. Now it's bam. I put on an extra negative sign. 'How to find the bounds? Okay. Yeah, that's the hardest part of the problem, I think. New Ghost song out, new album next month. Ooh, it's good to know. Um, let me I want to listen to that ghost song. Let me cue it up and then I'll explain how I did the bounds. Satanized. Add to queue. We're just gonna skip to it. Okay, so for the bounds, uh you can think of the bounds of the integral we're given as just some region in the xy plane, and I try to draw that region. So I think of we're integrating with respect to x first. So x is going from inverse sine y to pi over 2. And so if x is arcsine y, then y is sine of x. Because, or at least we don't have anything tricky happening with the domain. We're ending at pi over 2, so we don't have to worry about inverse function stuff. And so I came down here and I drew sine of x between 0 and pi over 2. And I knew to start at 0 because of the y bounds. Y starts at 0, so that's how we know to start at 0 there. And then we end at 1, which is in agreement with x ending at pi over 2. So once we know that's kind of what the curve looks like, we have to decide if we're integrating in this region here or in the one I shaded in green. And I figured that out from the x bounds. We're starting from inverse sine y, that curve, and going out to x equals pi over 2. So it's like we're drawing you could even imagine like a horizontal rectangle starting from arcsine and going out to pi over 2. The reverse would be x going from 0 to arcsine y. Yeah, the arcsine is weird to deal with. It's arcsine of y, so it turns just back into a regular sine when we graph it. And so yeah, if you're fine with that, then like feel free to ignore me. But I'll just explain through like the next piece, which is now that we understand the region that we're integrating over, we need to express it in completely new terms. Well, they're going to look similar, but we need to kind of think about this with a fresh set of eyes, starting with y and then using x. So y is going from 0 up to sine of x now, because y is sine of x. So instead of horizontal rectangles, we're drawing vertical rectangles. So that's why I got these bounds here. And now that we've dealt with the sine of x piece, we can just make x be normal numbers. So x is starting from 0 and going out to pi over 2. So that's how I got the 0 to pi over 2. So yeah, I hope that helps. That song's all right. I don't know if I'm like in love with it though. To be fair, I was doing calculus at the same time as listening to, so maybe that's not like the fairest chance. Okay. Think of the question, Adam. Unless you ask me anything else, I'm just going to go back to the problem I was working on before. Right here. Okay, so Yeah, it's definitely not bad. Over M. And then we should involve D. Hey, Tyler. Hope you're doing well. I'm so annoyed these aren't canceling. Should I be getting a different sign? Did I mess up my mental math? No? I don't think I did. Doing well, about to do some sim racing because you're a nerd with a sim now? Ooh. Like, what level of sim is this? Like, do you have like a steering wheel, or do you have an actual like thing that you sit in that feels like a car, or like what does that like look like? I can cancel a sign, I guess. I've got the wheel and pedals currently. No fancy seat yet, though. That's still pretty sick, though. Nice. Hope you enjoy. We had a simulation. All driving is sim driving. I love racing sims. uh, okay, the M's can cancel, the K's can cancel. One of these signs can cancel, and it can open up my eyes. So when the dust settles, we get a V naught out front, get a root, sine theta minus cosine theta over sine theta plus cosine theta. Like, we could make that tangent. I don't know if that's better or worse, but we could. Like tan theta minus 1 over tan theta plus 1. Oh, mu, 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 mu. Hey, Mew Mew, what's in that picnic basket? So we could do tan theta minus mu over tan theta plus mu. I don't know if that's really all that important, but why not? Ta-da! I think it's just... Wait, yeah. The units do check out still. Oh wait, no, we can do a check here. Is this less than V naught? It, like, this should be less than 1, whatever this is. Is that true? If mu is exactly equal to tangent theta, we get 0. That feels okay. That's like the critical mu. Like, it'll exactly stop. at the end. If mu is less than tangent theta, we do get a number that's less than 1. This seems reasonable, because I forgot, in part C, we got that relationship there to let us compare mu and tangent. I think this is okay. I feel better about the form of the answer that I got now. I'm gonna check. I think now it's time to check the answer key. 16? Okay, spring force, kx sine theta. Normal force, kx sine theta cosine theta. I put a minus sign in front, but I think that's just by convention. I don't think the minus sign is all that important. God, I gotta use the bathroom so bad. And then friction force, you just slam a mu in front of the spring force. Yeah, they are really clever. Dude, I can't. Why does it just like randomly hit me? I'm gonna use the bathroom quickly, guys. I'm sorry. Okay. I need my grandma blanket. Wait. Good. You know what? All that talk of embracing sims makes me kind of want to play one now. I also just heard that making a remake for Tony Hawk Pro Skater 3 and 4. I grew up playing 2, and I know there's a remake of that I never got around to buying, but like it got me like thinking about it again. Work spring, work friction. Is that right? Got that right. Huh. Interesting. These limits make sense. I just like the implication of that sentence. Like, I don't just like explain it anymore. It's just like they make sense. You're wrong if you don't think that. Tan theta greater than I said greater than or equal to. I should have done strictly, but I did get the right inequality otherwise. Oh my god. This entire problem is basically a block on an inclined plane. Except instead of a constant acceleration due to gravity, we have the varying force of the spring. But even then, technically gravity does drop off with distance. I guess the square of distance, but it's funny. I feel like I've been tricked now after reading the remark that's basically a block on an inclined plane. These results make sense. Um, oh, come on, Morin. You don't get them in terms of tangent. That makes it so much more instructive, to me at least. Although the music of zero is a clever thing to check. Okay, got that one right with some help. Um, I feel like I should just move on from this chapter. Like, should it, like, how long is the, I could just read through the bit on momentum quickly and start working on that. I think that's what we're going to do. Actually, it also means I should start up a new journal plus plus file. Give me 1 second. Okay. Momentum factorial. Mm-hmm. Okay, impulse? Really? I remember learning that impulse is like F delta T or something. Like, and delta T is very small. Multiply both sides by dt. Good old physics. Yeah, impulse is just change in momentum then. Ooh, this last sentence here is interesting. Time integral of force is momentum. The space integral of force is kinetic energy. Okay. Conservation of momentum. Can regulate the force on the ith particle into internal and external forces. Hmm. That is an interesting like point there, Bluebird. Like, what is the definition of content in this statement? I feel like he might even make like he might say the same thing about F equals MA, to be honest. Hmm. Maybe not. Yeah, I'm not sure. I guess F equals MA is more like an axiom, and J equals integral F dt is a definition that's not necessarily an axiom, it's just derived from an axiom. The definition was the content. I guess the content starts once you actually do something with it. The definition. I don't know though. Like a definition is useless if you can't use it for something. It's maybe the mentality. How long is this? This one's relatively longer, to be honest. This goes up in the chapter the center mass frame. Okay. And one D elastic equation, final relative velocity between two particles equals the negative of the initial relative velocity. Do they have the same mass? Not the same mass. So if two particles collide, one's going 2 meters per second, one's going 1 meter per second. They're just going to trade velocities regardless of their mass. It feels weird. Well, yeah, so I guess in my example here where they're colliding head on, that is not a very straight arrow. If that's 2 meters per second, that's 1 meter per second. The statement to me is that, you know, the afterward, the one on the left is now going 1 meter per second. The one on the right is now going 2. A person on this particle would see the other particle coming at them at, I guess, 3 meters per second, right? And then afterwards, someone on that same ball would see them going away at 3 meters per second. Why doesn't the velocity matter, though? If I assign them both masses, like this one is also 2 kg, and that's 1 kg. The initial velocity is 5. No, that's not conserving momentum. The scenario up top has total momentum 5. The scenario on the bottom has total momentum 4. What gives? Oh, momentum's a... I should be doing negatives, is what you're saying. So it should be like, say this to the right is positive. We'd have 2 times 2 plus 1 times -1 is 3. Here we'd have 2 times -1 plus 1 times 2. Well, that's even worse. I don't get what that statement is saying then. Let me reread it. Maybe they're not... Okay, they... Maybe I shouldn't assume they're trading velocities then. That has to be it. The velocities will still sum to 3, but not necessarily in this way. That's the only way I can think of to save this. Let's say that's V1. And that's V2. The total momentum is 3, right? I hope. So 3 is equal to 2 kilograms times V1 plus 1 kilogram times V2. I forget how you actually solve this. What's the other equation that we... Minus 2v1. If it adds to 3... Oh, I guess there should be a minus sign. V1 is going to the left. Well, or we should... I mean, I don't know. Yeah. I guess you're right. So wait, I mean, that's weird though, right? Because if V1 is 1, then V2 is 5. That's what would have to be true to preserve momentum. I forget how you would choose a particular V1 and V2. This makes no sense to me if masses aren't equal. I think they have to be equal. Collision is elastic. We know K is conserved too. Yeah. SpaceX Starship launch in 5 minutes. Oh, nice. um, that is cool to know. I'm not sure that I am gonna watch it, but you are. I definitely would welcome having a local space nerd here. Is it just a satellite, or where's it going? Experimental rocket test flight with no payload. Oh, okay, fair enough. Meanwhile, I can't figure out what a 1D elastic collision looks like. Like, it says two particles. I feel like the mass has to be equal. The biggest rocket ever made. Oh, that is cool. Maybe I'll Google the statement, but it says two particles. Like, I feel like this just has to be same mass. I don't want to tell the entire thing, but so these masses aren't necessarily equal. V 2xi is negative. Okay. Do I have a twin brother? No. Unless we were separated at birth. I'm becoming less sure now. Sit up? Okay. Oh, that's what you're saying with the kinetic energy in the Finlux. That's the other equation that we would need. Which one is the math guy? Which one works for SpaceX? Oh my god. You know, that is crazy similar. I don't know what to say. Did you just look up the launch right now? Moonlighting with Elon. Oh god. Okay, so I think I'm following, like, you can factor both of these as the difference of two squares. And then these two equations combined together, we know that this component is equal to this component. Wait, didn't they just assume the masses are equal here? No, they're dividing two equations. Okay. Yeah. Okay. They take this equation and divide out this equation. To get just the plus parts. What? They're referencing equation numbers without numbering them. Like, what is this? Um, they're just rearranging this equation to get initial with the initial. So relative velocity initial equals relative velocity final negative. Regardless of mass. So there must be some... Okay, let me work out with my example then, because there must be some, like, combination of V1 and V2 that make this true then. So kinetic energy is that 4 plus a half? Times 2v1 squared plus a half times 1 times v1 squared. And now that's the second equation. I guess we need to do substitution here. This fact just feels so weird to me. I don't know why. That's why I'm like going down this path of trying to prove it. At least in this isn't a proof, but investigating this example problem. Too many v1s? Oh, there sure are. I just really like v1. It's a great velocity. So v1 is -2. Which would make v2 also negative? What? I'm getting the wrong sign. Does the direction matter for kinetic energy? Do I also need a negative? I guess I do. Like, this one should have been negative kinetic energy. Is that a vector? I guess it has to be. They're scalars? Oh. Benga, I'm trying to verify this bullet point statement with an example that I made up, because it just doesn't feel right to me. But like, if I'm getting v1 is a negative number when I already built a negative sign in, that would mean v2 is a -1. And that just, they can't both be negative, right? Unless I drew my picture wrong. Isn't it possible that if two things collide head on, if the first one has way more momentum, would they both end up going the same direction? Is that a thing? That seems like what I'm getting, at least. If I didn't make a mistake earlier on. No, I did make a mistake earlier on. I canceled the 1/2 and the 2. No, I didn't. Uh, I'm trying to verify this statement, Banga. Take a screenshot of it if you want to like read it more, but I want to have the other window up so I can keep trying to check it. I made up an example over here to try and check it with, but it's not working out. Um, -2 for V1. I would get -1 for V2, so that's not even the right relative velocity either. I keep making V2 into V1. I corrected it later anyway, but did I... V2 is 3 plus 2 V1. 9, 12, 4... No, that's okay. Well, we can always just say that physics is wrong and I'm right, Fembox. I would love that conclusion. It probably is a sign thing. Wrong thing, the 2 negative. Should we just remember that it's... I mean, we can just try it to see. Really? You select everything that I didn't want? Like, remember that the negative is built into the thing. Damn, that did not go well, Jed. That doesn't sound like it went well. Maybe there's still a silver lining somewhere, but... Or they expected certain things of that to go wrong. They had to catch the booster before that, though. Okay. That becomes a -12 V1. That would give us a +2. Well, isn't... We said V1's supposed to be negative. We're supposed to get a negative result for... Oh my god. Bruh. Maybe we just need... I'm sure this will... I have no idea how you use this fact, and maybe that's going to avoid using it until we get into some example problems. Because I don't know how this is supposed to work. I'm sure like there's going to be some... In some problem solution for one of these, there's going to be some stupidly simple way of figuring this out. Or thinking about it in terms of like... If the masses have a certain ratio, that forces the velocities to have a certain ratio, and you can figure out what the one-right arrangement of velocities are, but I don't know. Defining center of mass. Given some part of the object can be replaced with a point mass. Right, yeah. Oh, so this holds for velocity and accelerations. Oh, okay, yeah. That's the explanation for the idea that I've seen before, which is you can count the entire system as one point mass. Same with the forces. When viewed in the center of mass frame, mass is head towards the stationary CM. Reverse direction head out at the same speeds they originally had. That's basically what we were just trying to do. We're supposed to take 0? I thought that was a garbage answer. I guess we're supposed to know to throw out 2 because it's positive? Okay, if V1 equals 0, that means V2 equals 3. 2 is the garbage answer because it's positive, I guess. Okay, and that is the right relative velocity. Wow. Okay, fair enough. Thank you, Pinbox. So how am I thinking about this then? Yeah, I thought it's really weird to me that the heavier and faster one just stops dead. Maybe I'm just bad at pool. Or that's why I'm bad at pool, because that's just weird to me. The masses. Wait, but then what the hell is with this statement here? It's simply a reverse direction at the same speeds they originally had. We just showed a scenario where one of them stops. Oh wait, in the CM frame. In the CM frame. In the CM frame. Okay. Fair enough. I'm not going to try to do the math of that, but I can believe that. Relativity stuff we did in the Purcell Morn book. Hmm. I mean, frames are involved, yeah. I said I need to see more of what we're gonna do with them, I guess. I mean, yeah, the special relativity that we learned is completely. It's not particular to E and M. Are we actually getting into gamma and beta in this chapter? Okay, it doesn't look like it, at least unless it's in a problem. I mean, I think Stuki is the one who really carried us. Because Stuki's, oh, not another Atwood's machine. Oh. Because I think Sugi had seen special relativity before. I could kind of get it, but make sure momentum energy transform correctly under action of the Galilean group, and you're also. Oh my god. Galilean group. I swear I just heard someone talking about those. I'd never heard of them before, but like I swear it was literally just yesterday or something. I heard someone talking about a Galilean group. That's where they hear about a second time, but I don't know. Now we need to Google it. Galilean group. No, I'm sure it's not just buzzwords. I was like curious. I've heard like this term come up twice now recently. Oh, okay. So that's like the simplest case of, or maybe not the simplest, but like a really simple case of transferring between frames, where there's a constant velocity is the only difference. Or maybe there's more than that. That's the Galilean transform. General case of the transformation between frames. Okay. Frames of like accelerated frames. Okay, fair enough. Ooh, there's the linear algebra version of this. That makes sense. I just learned from String that you can think of Kirchhoff's, I forget how to pronounce it, but his laws in terms of linear algebra and like with like circuits looking like graphs. I forget exactly how all that worked, but like the null space is the case where like all the potentials are equal or something. Um, yeah, it's just like I was watching like it was like a linear algebra lecture, so he couldn't or he didn't really explain the actual physics of what's happening in the circuit, and so I would need to do like I need to like work that stuff out for myself. Um, but it's still cool to see that's actually like a thing. Also, I thought it was funny that because he forgot the extra H in Kirchhoff. The Galilean group, it goes really deep. In Landau and Lifshitz mechanics, they derive that energy when f mv squared based on Galilean transformations. Really? Hmm. Man, I do want to study all the things like. Ugh. So on spin 1/2 is allowed to see a projector representations of the Galilean group. Really? It was like crack to you. No, you're getting me like genuinely interested in it. Because I had no idea that you could, or I would have assumed that that sort of relativity stuff only applies for like really big scale things and not like the spin of an electron. Oh, I guess I know it applies for like current running through a wire, which isn't like, planets orbiting each other. No. What am I? Wait, okay. If you want to solve a collision using the CM frame, instead it was given the lab frame, switch to CM frame. Hmm. I'm gonna need to try this out for myself. I'm sure there's gonna be at least one problem where this is helpful. But it's cool they're literally like just talking about using a different frame before even gone to relativity. Can we do a product roll there? Papadoria. One generalization problem come with my real analysis class. What is the closed formula for cosine 2 pi x in terms of cosine where n? Mm, yeah, I know this is like very soft relativity, I guess, or like very like gentle. Um, But like that book that Cook was talking about, Gravity, I still really want to do a reading group on that. I assume I should be really strong with this stuff. At least up to chapter, like up to and including chapter 10, I'd like to do from this book. I'm not making progress very quickly though. Um, let's think about what Papadori is asking us though. That's to the end. Okay. No worries. Galilean relativity is much less scary. Different frames equals Galileo's observation that butterflies flying in the hole of a moon ship fly just as well as if they were on stationary ground. I didn't know that he made that observation. Because like the observation that Einstein had with like the trains and stuff is like the famous one that I have heard about. But that makes sense, yeah. We did read that ship story? I don't remember that. Was it from like the when Pensioner is going through the red book? 'Cause I don't remember that from the green book. Sorry, Puppeteer, I just want to read this quick. Do you have a rotating Earth as opposed to stationary Earth? The Earth is rotating, there'd be detectable effects on the trajectories of projectiles or falling bodies. I remember this, like Galileo's on house arrest for a good portion of his life, right? Wait, what's the actual answer to this? I feel like it should go at the base of the mast? They're not saying what the actual result is, which is bothering me. I want confirmation that I'm not crazy. Okay, fine. I'll look into it another time. Um. Oh wait, that I misread that N is pi. Um. We need double angle formulas. That's the menu to choose from. So cosine 2 to the n x. I don't know what one is best, to be honest. Middle one? All right. Cosine 2t minus 1x minus 1. Um, things are going to get out of control here, are they not? Because we can write this now as the same thing. Unless we get some simplifications here. Oh, well, okay. Sure. Um, this is going to become... Maybe I should start from simple cases, and I should go the reverse direction. I think I can kind of see where this is going to go. We're going to get like 2 to the 2 to the n, maybe? Like this is going to be 2 to some power of 2. But let's start from n equals 1 and build up. Two, nope. What happens when we simplify that? That'll become 2 cubed cosine to the 4th x. Oh no. Oh, this foils. I didn't think about that. Eight cosine to the 4th minus 8 cosine squared plus 1, same. We're going to get new terms every time, which is the weird part. I think a summation is going to be okay. We're probably allowed those. Because this is a patented Papadoria question, so it's not going to be simple. They expand an exponential function as a series. Oh, like the complex definition of cosine? That could be a really nice way of doing this. Oh, this is a real analysis class, you said, though, Papadoria. They vanished. What is cosine plus? I think it's plus. Well, let's just see if the complex variables way can make this simpler. Because the trig identities way is going to be... It looks like it's going to involve a summation. There you go, underscore. I'm verifying my cosine. Oh, okay, I got cosine right. I didn't mean to go off on a tangent. Are you going to cosine alone with me? Oh my god, Mega. Math should be illegal, it can take over you, make you go crazy. That's very true, Vanished. Okay, so if cosine of x is that, then cosine of 2 to the nx, like a firecracker at the beach going off on a tangent. Oh my god. That one's a huge stretch. Wow. Didn't Newton go crazy studying math? I like to believe Newton was always crazy. Crazy? I was crazy once. We can factor out an e to the 2n from this, right? No, we can't. We can't do that. Be nice if we could do that. Newton's obsession with alchemy and the philosopher's stone, or his theology. Oh, I mean, my mind always goes to, his choice of reading material. I don't know how to use the complex thing. A series might be more realistic. Um, the question is there at the top. Simplify cosine of 2 to the n times x. So at first I was trying to go at it with double angles, but that gets a little crazy. And then the complex definition, I don't see where it takes us. So how about the series? Oh, it actually will give you Chebyshev. I mean, I don't know where you go from here. Oh, the mobs. Oh, that's sneaky. This is from a real analysis class. Um, but let's just use imaginary numbers, at least to get an answer. Okay, so if we think about cosine of just x plus I sine x to the power of 2 to the n, that's equal to cosine of 2 to the nx plus I sine 2 to the nx. Take the real parts of both sides. Okay. Well, I'm not quite sure what to do with the we're gonna have to do some thinking on the right side. Or left, by right I mean left. Binomial theorem? Um Oh. Wow. Okay. We just well no, I can probably remember if I start to write it out. Um A plus B to the n is equal to the sum from k equals 1, no, 0 to n. N choose k, a to the k, b to the n minus k. Oh, that's so sneaky. So cosine x plus I sine x to the 2 to the n. Yeah. Nope. 2 to the n. 2 to the n choose k. All terms that are real have an even power of I. Ooh, thank you. Yeah. And 2 to the n minus k is even when k is even, because 2 to the n is guaranteed to be even. So can we rewrite this series? I guess so then the real part, we can, I guess, re-index the series. And to take just the even part. So we're only gonna get half the terms, so we take our ending index and cut it in half, I hope. I wonder if we need an extra -1. I don't know though. What am I trying to do? I guess it's gonna be right. Hey Joel. You want only the even k, so times 2k like that. Everything is 2k now, I want to say. I don't know, is this necessary? Should I just be... Maybe I should just write out the terms and make the pattern based off those. Choose 0. Different variable than k. Okay, I can try to go. I can try to make a summation with just the different variable. Yeah, Joel, I can look at it after this. So we want 2 times j, right? If everything is 2j. Okay, and then we want to deal with the I. This is always I to an even power, where we care if I is... Yeah, we do care if it's what it is mod 4, right? I squared is an I to the 4th. Um... Oh, do they have the exact problem here? Or let me see what this thread is. Oh, I did forget it. Well, wait. All right. I see you, Joel. You'll be right. Or you'll be next. Yeah, we used them all. Oh, so this isn't the exact same. So they have just n. Yeah, they're expanding cosine nx. We can replace n with 2 to the n. Can we make that a sine squared to replace it with cosine? That's just good form, I guess. Um, I think we're just getting a -1 to the j. Now we get rid of the I, make it 1 minus cosine squared. And so then the new exponent is going to be 2 to the n minus 1 minus j. So we brought a squared inside. This is technically the answer, I think. Yeah. I don't like that this uses complex variables or complex numbers in a real analysis class. It's probably the easiest way to do it though. Like I do just like this way. I'm just looking at the other answers here. It is what it is, Papadoria. Yeah, I guess so. I'll pass on the Stack Exchange link to you if you want to see it. It's for cosine of nx, so it's not the exact same here. Yeah, Mega, that's what I assume that's the intended strategy. It gets really messy really quick. Um, doing it the double angle way. But you do end up with a series with powers of 2 in it. So I think you could, if you went through the pain of getting a few terms to look for a pattern, you should theoretically be able to find this same series, I think. It's just the complex variables way is way easier if you know what to do at least. Okay, yeah, fair enough, Papadoria. I do want to take a look at Joel's problem here. Time is it? 4:30? Okay. Joel has a double integral for us. You have to go anyway? All right. Thank you for the question. See it. Yeah. We have another bounds switching one. Second one today. Okay, so Joel, I don't know if you're here, Joel. Are you here? I'll still go through and start working on the question anyway, but I'll type your name in chat too in case that helps get your attention. You're still here? Okay, cool. Thank you. So trying to integrate cosine of y cubed directly seems terrible. I don't know how you do that. So I think we need to switch the order here. Territor, I assume we need to switch the order and we hopefully get something that works out. That's my best guess of what's going to happen here. So if we want to switch the order, we do have to figure out what our bounds are going to be. So y is going from root x to y equals 1. So root x looks like that. When x equals 1, y equals 1. So, and then x going from 0 to 1. So we're integrating over this region here, because y starts from root x and goes up to 1. So now we need to re-express this region with integrating with x first. So x's go from 0 out to this sideways parabola. if y is root x, then x is y squared. So from 0 to y squared. And that'll give us a u sub. So this will work. And then y is simply going from 0 to 1. Okay, so let's do this. And here with respect to x first, we get x cosine y cubed. Derivatives, equalities, and integration? It sure does, Meg. Oh my god. Hey, SG1. And see, Joel, I think the bound switching is the most important part of the problem. So if you have a question on that, please do let me know. But I'm just going to proceed with solving the integral. So for x, we plug in y squared. And then we plug in 0, but 0 doesn't give us anything, so I'm not going to rate it. Now we have a single variable integral. Let's say cube equal to y cubed. So d is 3y squared dy, and that's why this integral becomes a lot easier. I'm going to drop the bounds for now. That y squared cancel with that y squared. We do get a 1/3 cosine of u du. Cosine integrates to positive sign. So 1/3 sine u. Now we unsub sine of y cubed. Now we evaluate from 0 to 1. So we get 1/3 sine of 1 cubed is just 1. And then we would subtract off 1/3 sine of 0, but sine of 0 is 0, so who cares? Sine of 1 we can't simplify, so I say this is just our answer here. 1/3 sine of 1. I know Fembox, like, especially like that one ended up with tangent of 1. This is sine of 1. It's funny. Let him cook. No worries, Joel. Hmm. We didn't actually do a momentum problem, did we? I'm gonna skip over the multiple choice ones and go straight to the... These ones seem important to do first. Let's see if we can at least do one, and then I'm gonna call it, I think. The forces cancel in pairs. I'm sure this isn't that hard, but I'm trying to figure out how it's supposed to be phrased. something like they say on particle I due to particle J. Oh my, I need to figure out why that happens. Thank you, $10. So Fij plus Fji is 0. And I think now we want to sum everything up. I assume this is what we want to do, or something like this. Where am I going with this, though? What do we want to get? I guess we need to do this part first. Um, so then, I guess by our definition, the sum of, I guess, I t plus dpj dt is 0. And we want to we can take the derivative all the way outside. By properties of the derivative. Can we? Wait. Yes. Because f plus g prime is f prime plus g prime. This is all things being added linearly. Yeah. Hey, Hornby, do you agree? Okay. These are vectors, by the way. So, so are the forces. I don't want triangles on everything. Who cares? I guess now if we integrate, we get all the momenta equal a constant. Now, I'm not a fan. I haven't really defined the summation. in a very like rigorous way. I feel like I like, am I getting I's and J's repeated here? Like, is P1 showing up multiple times with how I've done this? Because that would imply, unless they all have the same coefficient. Um, like it's fine if we get 2p1 plus 2p2 as a constant, because oops, you know, I just include the 2 in that constant, but it would be terrible if we got 2p1 plus p2 as a constant, because that implies p1 as like half of p2. I keep writing 0. 0 is a constant though. And so I'm trying to figure out whether I'm what scenario I'm in here. I think every pair of particles. You're graded for graduate course at your school now? Ooh, nice. What type of course is it? Advanced engineering courses, nice. Are you a student as well? Sorry if you said that before. It's been a minute though. So your senior year. Okay, nice, nice. Semester. Okay. I think that we can make the argument that this summation is over all pairs of I and J, and that if we do get repeats, everything is going to repeat the same number of times. So we could just divide out whatever coefficient that is. And set equal, I mean, some constant will be equal to some other constant. I think that's the argument that we would make. Let's check that. Avert your eyes from number 2. Well, wait. You can't just do it for n equals 3. Well, wait, so if Fij... Oh, okay, F1 is the total forces. This is like a proof by induction where you only check the base case. I think I mean, my way is needlessly complicated, but I think it's okay. Yeah, you're throwing shade to today at everyone, Fembox. Every physicist at my math. I'm just gonna say that I'm right because that makes me able to sleep better at night. Yeah, you're going off. Um. All right, I think we're gonna wrap it up here though. There is gonna be a class tonight. Um. So yeah, I think we'll wrap things up here. So anyways, here on YouTube, thanks for being here. I plan to be back on YouTube on Saturday in 2 days. See ya, bye YouTube.